Hey guys, so here's our next week's notes on atoms and subatomic particles. So I know that you guys are ready to move past anything to do with solid, liquid, and gas, and Mr. Golden and I are also ready to move on. So this week we start something completely different, and we'll be talking about this kind of stuff for probably the next 2 or 3 weeks. But the rest of the semester will build on what we know about this. So we want to make sure that we have a good understanding of what we're doing in this unit. So our first thing that we want to know is, what is an atom? And you probably have already studied atoms before, but an atom is the smallest unit of an element. So if I make an element if I take an element and I break it down as small as I can, and it's still that element, it's going to be an atom. If I break an atom down, I can break it into its parts, which we'll talk about in a second. But for instance, if I take an atom of hydrogen and I break it down even further, it's not going to be hydrogen anymore. It's not going to have any of the properties that hydrogen has. So an atom is the smallest amount of an element that still has all the properties of the element. And an atom has a nucleus, and they're surrounded by at least one electron that's kind of moving around the nucleus. So we're going to talk about all these parts one by one. All right, so if we just look at the nucleus is the middle of the atom, in the very center. It's made of protons and neutrons, which we'll talk about in a second. And this is where most of an atom's mass is located. So if we say that an atom has a mass of 12, most of that 12 is going to be in the nucleus, because electrons are outside the nucleus and they're very tiny, so they don't really take up that much mass. All right, so one of the things in the nucleus is a proton. And a proton is the part of the atom's nucleus that carries a positive charge. So in this picture, I want you to draw this next to the definition and just draw a circle with a plus sign, so you'll remember that it's positive. And I like to remember that protons are positive because they both start with P. So if you can remember proton, positive, you'll be good to go. Okay. Now the other particle, subatomic particle that's in the nucleus, is called a neutron. And this is the part of the atom's nucleus that carries no charge. So it doesn't have a charge. It's not positive and it's not negative. It's just neutral. So I like to remember that neutrons are neutral and they share, it's basically the same word. Neutr is in both of them. So that's easy to remember. Okay, so when you draw a picture, don't put a charge for neutron. Okay, it's just blank. So those two make up the atom's nucleus. So those are big subatomic particles. Most of the atom's mass is going to be in the protons and neutrons. Now we're going to go to the electrons, but the electrons are very tiny, so they really don't have an effect on the atom's mass. So an electron is a subatomic particle that whizzes around the outside of the nucleus and carries a negative charge. So I use the word whizzes, or you could say buzzes, or flies, or spins, but basically electrons just kind of whir around the nucleus, and they just kind of buzz around, but they're not inside the nucleus like a proton and neutron are. Okay, so they have a negative charge. You can draw a small circle with a negative charge inside. Now, I don't have any cute ways to remember that electrons are negative, but if you can think of a way, then you're welcome to use it, and also let us know what you come up with in class. Maybe everybody could use it. But also, I know that if protons are positive and neutrons are neutral, then the only thing electrons can be is negative. So you can do it by process of elimination like I do, or you can think of a way to remember it on your own. Now, the periodic table actually gives us a lot of hints about the nucleus of an atom. So one part of the week, later on, probably Wednesday and Thursday, we're going to be talking about how to figure out the number of protons and neutrons and electrons based on the periodic table. So if you look at an element on the periodic table, there's usually a number at the top that's a whole number. It's never a decimal, and that's the atomic number. Then you have the element symbol. So carbon is C, silicon is Si, hydrogen is H. So it's just a way to abbreviate the name. Then you have the element's name. And then normally at the bottom, but not always, you have the atomic mass. And the atomic mass usually has a decimal. So the way you can figure it out is a lot of times the mass is a decimal, whereas the atomic number is not. And also, the atomic mass is generally bigger than the atomic number. So if you're looking at an element and you're not sure which one is the atomic number and which one is the atomic mass, the bigger one is probably the mass. Okay? So we can use the atomic number to figure out the number of protons because the atomic number is equal to the number of protons in one atom of that element. Now the atomic mass is the sum of protons and neutrons. So if I have 2 protons and 3 neutrons, my mass is going to be 5 because it's protons plus neutrons. Okay? And then since protons and electrons are equal, we haven't really talked about that yet, but since protons have a positive charge and electrons have a negative charge, they cancel each other out. So we normally have the same amount of protons as we do electrons. And so if we have 6 protons, chances are we have 6 electrons, which is why the atomic number can also help us figure out the number of electrons as well as protons. We'll be talking more about that in class. So if that part confuses you, don't worry. Just copy it down and make sure you're listening and asking questions in class. Now, so let me show you an example of how we would use this element to figure out what the atom looks like or how many protons, neutrons, and electrons it has. So if we take this same element, carbon, and let's say we are asking ourselves how many neutrons are in one atom of carbon. We're going to look at the element and we see, okay, that there's a mass of 12.01. And we remember that mass is the protons plus the neutrons. So if we can figure out the number of protons, then we could subtract it and get the number of neutrons. So now we remember that the atomic number at the top equals the number of protons. So here I am, I know that 12.01 is protons and neutrons. The atomic number 6 is the number of protons. So if I subtract 12.01 minus 6, then I'll get 6.01, which means I can round, right? It means that there's about 6 neutrons in an atom of carbon. Okay? So it's just a little practice problem for you to look at. If this is totally new to you, you've never done this before, don't worry. We're going to unpack it in class and go through it step by step. But for some of you, I know you've done this before in middle school, so it's like a review. So if you still have questions, make sure you let us know and have these notes in on Monday and enjoy your long weekends.